Sorry, hello, are you there? Guys, are you there? Are you people there with me? Now, can you hear me? Just let me know if you can hear me. I was speaking on mute. Sorry for that. I did not see that. I just saw your messages that I was not audible. Okay, so Puneet says he can hear me. Padmani, you can also hear me, right? Hey, Shali, I think I was speaking on mute. It was not the problem with you people. I was just keep on speaking on mute and I just saw your people messages. Okay. So I'll repeat everything. I hope. Okay. And I was just wondering why no one is speaking up. And you can just unmute yourself and just say so that I can hear up. I was just speaking on mute. And okay, I'll repeat everything. And okay, I'll repeat from start. I don't know where you people lost up. So there are three phases where you can apply compression, and compression is very useful for you to boost up your processing power of the Hadoop cluster. How that is helpful? You are reading less data, you are emitting less data, and you are transferring less data from the mapper phase. When I'm saying you are reading less data, and you are doing less IOs because your data is compressed, so you are reading lesser data. How you are emitting less data? If you are compressing the data from the reducer phase, you are emitting less data and you are writing less data, so again you are doing less IOs. And if you are compressing your data out of mapper phase, that is your short and shuffle phase, you are transferring less data over the network. So compression is always helpful to boost your processing power of Hadoop cluster, and you should always be looking at compression. However, this will make your cluster CPU intensive because to compress or decompress you require a lot of CPU cycles, but you have to precisely choose a point where you want your compression level and where you want your CPUs to have good processing. Basically, have processing power to process your data and not waste all the CPU cycles into compressing and decompressing. So you apply compression at three phases. There are these four native compression technologies available with Apache Hadoop for you. You don't have to import anything for that. These are available for you with Apache Hadoop. ZZip, BZZip2, LZip, and Snappy. ZZip and BZZip2 gives you pretty good compression ratios. And when I'm saying pretty good, they gives you up to 70 to 80% on your raw text files, or server logs kind of thing, where your data is almost similar and your data is in a text format. LZip and Snappy gives you less compression as compared to ZZip and BZZip2. However, they are faster as compared to ZZip and BZZip2 because they are doing less compression. So ZZip and BZZip2 use extensive CPU. However, LZip and Snappy do not use extensive CPU as compared to ZZip and BZZip2. So these two gives you less compression, however are faster. These two gives you good compression, however are slower. And if they are giving good compression, definitely they will be requiring more CPUs. However, the point which need to be noted over here is splittable. So some file formats are splittable, some are not splittable. I want someone of you to please comment up what does this make, how splittable will really help you while you are doing the processing on the Hadoop cluster. So one of you please come up and tell how that would be helpful for you. I'm audible now, right?
Yes, you're audible. I'm sorry, I was getting coffee.
So do you want to comment how the split table will help me out, or
No, I don't think so. I think I'd rather listen to someone else right now, but I'll get you the next one.
okay? Anyone else want to comment? Okay, no one want to comment. So I hope you remember that what is split table, how the mapper and reducer phase talks about the split table. If you remember the previous session, I told you one mapper equivalent to one split. So number of splits equals to number of mappers created in the cluster. So if my file is not splittable, say I have a data of 1 petabytes, and if the file is not splittable, so I say I have a file of 1 petabyte, 1 PB. I compressed it with ZZip2 that is reduced to say 250 GBs. I'm just assuming up, so 250 GBs. But the file is not splittable. So only one mapper on this file. So this file is being processed by a single mapper, and while this file is processed by a single mapper, you can think of what will happen at the back end. All the data would be transferred to one data node where that mapper is running up, and this file would be lying across different data nodes of 64 MB or 128 MB. So first thing, there's a lot of data transfer is happening at the back end because the file is not splittable, and the data will be transferred to one mapper. Second thing is I am not doing parallel processing on the file. Not only the data is transferred, but I am not doing parallel processing on the file because only one mapper is reading this file and doing mapper phase on this file. So if your file is not splittable, only one mapper, if you can recall my previous class, and if only one mapper, you can think of what is the havoc you are creating on the cluster. So if your file is not splittable, you have to precisely choose the compression technology if you are splitting your file or not. So ZZip and Snappy is not splittable, and BZZ2 and LZO are splittable. LZO is splittable only if this is indexed. So while you're creating LZO file, there is an option to index the file, and if you index the file, this is splittable. So now, anyone want to comment up on which phase of the whole life cycle? The phase 1 is your reading phase, the phase 2 is short and simple phase, and the phase 3 is writing phase. At which phase you think you want to use which compression format? So while I'm saying reading phase, that is my input data. While I'm saying short and simple phase, that is the data emitted out of the mapper. And while I'm saying writing phase, that is the data emitted out of the reducer. Anyone want to comment on which phase you want to use which compression?
Well, I would think that you'd want to use the splittable compressions during the sort and split phase. Is that right? So like bzip2 or?
No, not really.
No. Okay.
What I'm saying is, reading is your mapper is reading. So splittable is only comes in picture while you're reading the data, because then only your multiple mappers need to be created up, right?
Right.
So now again you can think of.
So then you'd want to have the splittable at that phase, right?
Yes.
Okay.
But again, one more thing you have to think of. So I'm just trying to give you people the clues. When you're putting your data into SDFS, you want you are also paying for hard disk, and the hard disk cost is not minimal if you're using AWS or any private clouds. So your managers or your product managers would definitely keep on troubling you to reduce the cluster cost also. So you always want your data to be in a compressed format while you are putting up at S3, that is AWS formats, or in SDFS file formats. So you have to think of precisely where you want to use which compression, so that your mapper and reducer are also running pretty fast. However, you are not making your cluster cost pretty high, and you're not making your projects going out of budget. So now, any comments? Okay. So let me talk about so ZZip and BZZip are the two compression which you might be using over here or over here, because this is a data which is being sent to the SGFS part, and this will definitely reduce your IOs, so will make your MapReduce faster because your data is highly compressed. And not only this will reduce your IOs, but this will also reduce your cost of maintaining the cluster, because you are using less storage cost on the cluster. Be it AWS, be it your private clouds, be it anything, you are using less storage. But if the file is not executable, definitely now your doubt in your mind is you are using single mapper. So over there you can use BZZip and ZZZip also, but there are some file formats which can make your ZZZip come splittable. We'll talk about those file formats in some time. So you can use BZZip directly on the files, or you can use ZZZip in a particular file format, which I'll talk about in some time. In these two phases, that is your data which is lying on your Hadoop cluster or N2 SDFS. But when you are talking about short and suffer phase, that is the data emitted out of the mapper, there you don't want to waste your time in compressing and decompressing, because that is a CPU bound phase. So in that phase, you might look at LZO and Snappy while transferring your data over the network. And if your data is not splittable, also that does not affect the processing, because the data anyhow need to be sent to the reducer phase. Does this thing making sense? Pony says yes.
Yes, thank you.
Okay. Okay, so how to compress at different levels? Everything is configurable. So if you remember the MapReduce code which I told you, we'll talk about the high pick part in the later on. But if you're talking about the native MapReduce, you can just set output compression class and compress the output, and there you can just define which codec need to be used and whether the output need to be compressed. Similarly, if the input is compressed, you can just talk about them. So if you want to compress your data emitted out of the mapper phase, you can just say compress map output and what is the codec need to be used. So this is a slide which is talking about the compression of mapper at output, that is a mapper output, that is the short and suffer phase. You can just set these parameters and you can compress your data. So again, the example you can see in the Java code which I've shared with you. But these things will really help you or make sense in the next class where we'll be talking about Hive. So that will be very easy, but all these things would really make sense to you in the next class of Hive. So ZZip, as I already told you, is naturally or natively supported by Hadoop, and this gives you pretty good compression, but the file is not spreadable. You have to keep that thing in your mind. So if you are just reading ZZip file with your as your input data for your MapReduce phase, you are killing your cluster. BZZip, again freely available, already there on the machine which I've shared with you. No libs, nothing need to be included up. Whatever flavor you use, Cloudera or Hortonworks. All you have to know is it's give you pretty high compression, and some of the things which I've shared with you over here, like its compression speed is faster but slower than other formats like ZZip. So there are few things which are comparing up these files, but you should know the basic concept that the compression and the splittability. LZO is do not do not compress your data highly, but it's much faster as compared to BZZip and ZZip. So the speed is magnitude faster than ZZip, but the compression is slower, and this will be less CPU intensive. Similarly for Snappy, this is from Google, and this is again available on the VMs which I've shared with you. And this slide again compares. So Snappy is faster than Elgato in decompression. So there's a few things which might be faster somewhere. There might be few things which might be slower somewhere. But the major difference is Elgato and Snappy are differ by splittability, and similarly ZZip and BZZip are differ by splittability, and these four differ by the compression ratios which they give and how fast they are. They are giving less compression, they are faster up, and they are giving high compression, they are less faster. So so this is Hadoop. We'll look at this this thing. So streaming, I have not yet talked about Hadoop streaming. So this code will make sense to you when I'll talk about Hadoop streaming. So Hadoop streaming is really useful for you people if you don't know Java. You can write your code in any of the streaming language like Python, Ruby, R, and you can send it to Hadoop cluster, and Hadoop will run that as a MapReduce code for you. So this would be really useful for you. We'll talk about Hadoop streaming in our next classes. Any questions on the compression part? You should know the compression types. How to use them is pretty easy. All you have to do is just define that thing in your MapReduce phase, or you can define it in a pig and hive. How to define a pig and hive? I'll talk about that part while we are discussing about pig and hive. Any other questions in your compression thing before I move on to file formats?
No questions right now.
Okay. Okay, so don't worry about the complexity about these file formats. Just to keep the concept in the mind. This will make you think of what file format I have to use while you are, designing your application. So at different phases, you might be putting your different data in different file formats. And if you know what is the benefit these file formats give to you over the other, you can easily decide while you are designing up your application which file format you want to use for which data and at which phase of the life cycle of the MapReduce MapReduce which is running in a cluster, or the jobs which are running in a cluster. So you might change your file formats at different life cycle of the data. Just to understand the file formats, don't worry about the complexities of the file format, how to use them with the Java. You will never be using them from the Java. You will be using them directly from the Hive or Pig, or while you're receiving the file format. So first thing, sequence files. So they are pretty much useful as a holder to hold your data. So they contain blocks, and in the blocks you can put up your smaller files. So you can put up your video files, you can put up your images, you can put up your text files in the blocks, which are maintained by sequence files. How they look like is, so they basically work as a container for your small files. They can compress your data at block level as well as the record level. What is block? I'll just show you in the files. So this is how the file looks like. I'll just show that thing to you. And they contains pretty good thing, that is seeking. So while reading the file, if your reader is lost somewhere, or if you want to start reading from in between the file, with the help of seeking capabilities in this file, you can very fastly reach the record boundary and can start reading from there. So let's look at the file format, and then that will make a little bit more sense to you. So header, record, sync, record. So this is how your basically file looks like, and this syncs will help you to seek from anywhere in the file. If your reader is lost somewhere, you can very easily point to this sinks. How to do that, I'll talk about that part in some time. So your header contains your name of the keys and the value of the classes and the compression details or any user defined metadata or compression codecs about your file. And your record looks something like this. If the record is not compressed, your record would look something like this: record length, key and value. And here your record length is nothing but the length of the record, and key length is length of the key in your record. And if your record is compressed, it will look something like this: record length, key and compressed value. Not your key is compressed, it's only the value which is compressed. So key is not compressed. So this is how your file looks like. It contains your record by record data, and you can compress your data on the record. You can compress your data on the block also. How you can compress on the block, I'll just talk about that part. And they are in between sinks. How the sinks are helpful, we'll also look at them. If you compress your data on the block level, your file will look something like this. You have blocks, and a block might contain n number of records. So if your block is compressed, it will be something like this: number of records in that block, compressed keys, and before that compressed key lengths. So this will talk about the length of the compressed keys and the compressed value lengths and the compressed values. So there could be n number of records in a block. So you can apply compression at the block level and at the record level in these files. So this is how these files behave a container for smaller files. So you can put smaller files in the record. A record could behave as a smaller file for you, and you can use these files. So now, if your file is ZZZip compressed, and okay, before that, sequence files are splittable. So I have not mentioned it over here, but sequence files are splittable. That might be mentioned. Okay, I have not mentioned over here, but sequence files are splittable. So what you can do is you can compress your smaller files in ZZip format, put them in the sequence file, and you can use sequence file in a MapReduce case. In that case, you are making your ZZip splittable. How that is splittable? You are compressing your individual records in ZZip and putting that thing in sequence file, and this is how you can achieve ZZip file. Also, basically, you can create multiple mappers on your ZZip file also. So let's look at this file and let's try to run one program that will make sense to you how this things comes in picture. So if I start reading from somewhere here, so say this is my physical boundary in the map this thing Hadoop word. So this is your one block in Hadoop word. And if I start reading from here, this will not make sense to you, but I can easily sync in the file, and I can reach my pointer over here and start reading from here. So this is a logical start of the file, which from where I can start up with help of this sync pointers in the file. How those are helpful up, let me show you. I'll run one code for you and let me show you. So I have to start the VM that is not started up. So by the time my VM is starting up, if you have any questions, just ping me up or let me know by the time my VM is starting up. So does these things making sense to you, or these are just going away, or these are just making little sense to you? Yeah, Puneet, go ahead.
Okay, am I audible, right?
Yes.
Yeah. So, okay.
So no, Puneet, they are not documented.
I tried both the things. I mean, my earlier two problems. So I had no questions.
Okay, so that was a question from Sally. Okay. Yeah, Puneet, go ahead. By the time I'll read the Sally's question next.
Okay. So I have no question in the content which you have told just now. So
Okay.
only the two things which I asked in the starting. So I've been trying both of them.
Okay.
So I was saying I'm doing the content. I was, trying both the things. I have a question. So is this right time to ask, or maybe afterwards you will? So I tried both the things which you told me
Okay.
regarding that installation and
Okay.
that jar file. So I tried both these things, but again I'm facing few problems.
Few problem. Okay. So again I have to look at your left
So
at your.
when I ran that jar file from the local.
Uh-huh. Yeah, go ahead.
Okay, okay.
Go ahead,
So
go ahead.
when I ran that jar file from my, okay, so when I ran that, yeah. So when I ran that jar file from the local Unix system and my input data was on the HDFS world, then it is giving me an error that exception in thread main java.lang.class not found exception. So this is the error it is throwing up.
Okay. So the thing is, after you have to give a command Hadoop jar name, then fully qualified class name, that is starting from com dot something something dot 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 dot. That is what you would not have given.
Yeah, I have not given any class name. So
Yeah. So just give the fully qualified class name also.
So from where to get that class name?
You can just open your class name in the Eclipse and whichever class you want to run. So right now you are running this word count program. So you can just open that word count class, and at the end of the file I am also given the hint how to run it, or you can just copy the class name from there, the package name dot class name.
Okay. And another thing, Miraj. So when I that underscore thing, if you remember, so when I copied the content from that dot files, I mean underscore files to dot class path and those two files. So when I again after that when I started importing, so it is now showing me that thing. Now when I browse that, so it is coming up. But if I share my desktop, then only you will be able to see that.
Okay. So then let's look at that thing later on. But how to give that class file name? So just open this class word count class, and at the end of the file I've given the hint also what is the fully qualified class name, or the fully qualified class name is the package name dot your class name.
Okay.
So Shelly, regarding your question, actually there is not documented best practices which I can say you. What I'm saying or talking about right now is the experience. So not only the experience, but these are the things. So basically, what is written is what this file is doing or what this compression is doing. So you have to think of where you want to use them and how you want to use them. So when you'll be running your application in the real production world, at the first go, you will never be able to achieve your best performance. You always have to do hit and tries on your real production cluster. But if you understand what file format, what compression gives you what kind of benefit, then only you will be able to think of what to apply where and which can give you better performance on what is currently being implemented. So as such, there is no best, best practices kind of thing which is there. What I'm talking right now is my experience from last 3-4 years on different productionized application which I've done.
Okay, thank you.
Okay, so let's look at this. What I was talking about, sequence file, right? Sequence file. So I have few Java programs which are creating a sequence file for me, and then we'll be reading them. So here I'm just creating a sequence file which is nothing but writing these lines one by one and 100 times. So I'm just creating a text file, a file which is a sequence file, and having these records. The first record would be 1, 2, buckle my shoe, 3, 4, shut the door, and so on. And these files are repeated. These lines are repeated again and again in this for loop. So let's create a sequence file and let's look at that file, and then we'll try to read that file, and then I'll tell you how this seek really helps you in seeking the file from in the file if you are reading your file from somewhere on the blocks on your Hadoop cluster. So okay, so we'll just copy this command, and for that I think let me delete this directory also. So tomorrow I'll cover hives. That will be interesting for you people, and that you will be able to get very fast, and that is the majorly you will be using up. So, but before that, now you understand all these things. So the understanding the hive will not be a difficult task for you, and I am 100% sure you'll be able to get that thing very fast. But do not forget all these concepts which I have explained to you till now, because these are the things which are heart of the system. So what I'm doing is I'm just creating a sequence file. So this Java code is nothing. This Java code is nothing but creating a sequence file for us. So you can do it with the Hive also. You can do it.